Welcome. In this video, we are going to dive into one of the most essential concepts in the machine learning and optimization. In the previous video, we discussed regarding the mini patch gradient descent. So here I would like to discuss the stochastic gradient descent or SGD. It is a powerful technique. This is used to minimize the loss functions and train machine learning models efficiently, especially when we deal with large data sets. First, let's take a step back and understand the gradient descent in general. So gradient descent is an optimized algorithm used to minimize a function by iteratively moving toward the steepest descents, that is the direction of the negative gradient. The example which I gave in the previous video was similar. So imagine you are standing on top of the mountain and you want to get to the lowest point in the valley. Gradient descent help you find the lowest point by guiding you in the direction of the steepest slope. Now, this is the mathematical term, and this update rule can be written as the theta, where theta are the parameter of the models, and is the learning rate, controlling how large each step is. And delta change in the function is the gradient, the derivative of the loss function with respect to the parameters. Now let's talk about the stochastic gradient descent. The word stochastic means random. In traditional gradient descent, we compute the gradient of the loss function using the entire dataset, which can be computationally expensive for large dataset. However, in this stochastic gradient descent, we update the model parameters using just a single random point or a small patch at a time. This leads to faster updates and can be more efficient, especially when we have a large dataset. So in SGD, the update rule becomes, if I so here I have added the x and y, x and yi. So this represents a single data point from a data set and gradient is computed based on the point in this rather than the entire data set. Now, because the gradient is calculated using a single data point, the updates are noisy, which can make SGD less stable than batch gradient descent. However, this noise can also help the algorithm escape local minima and explore the lower surface more effectively. So in the case of the batch gradient descent, as you can see, if we use the complete data set and it goes to the local minima easily. In the mini batch, we take the random mini batch gradient descent and it's jump through the local minima and stays there. In the case of stochastic gradient, where we use the random parameters, it takes it easier and faster, but the disadvantage is very less stable than the batch gradient descent. So why do we use stochastic gradient descents? So here are the key reasons. Fast efficiency. The SGD is faster because it processes one data point at a time. Scalability. It works well with a large dataset that won't fit in the memory. And escape local minima. The noise in the IGT can help it to avoid getting stuck in the local minima, making it more likely to find the global value. Now let's look at the SGT works in practice. We will implement SGT in Python to train a simple linear regression model using NumPy. So here's our setup. We generate some, let me load the libraries. We generate some data, sample data for a simple linear regression task. Our goal is to find the line that fits the data using SGD. And let's visualize our data. So which is using the equation of y equals to 2 multiplied by x plus 1 with some MADI noise, and we'll fit the linear regression model using SGD to learn the parameter theta 0, the intercept, and the theta 1, the slope. So here's the implementation of the SGD for a linear equation. So we are randomly initializing the theta. So uh, theta 0 and theta 1, which is the intercept and the slope. Learning rate is zero point 0.1. The iterations are 100, and these are the edit bias and the function for stochastic gradient descent, SGD. So we are randomly picking the single sample here and then computing the prediction, computing the gradient, and updating the parameter every in each iteration. So let me run this. So this is our learning parameter. So this code, we have initialize our parameter randomly. We then perform the stochastic gradient descent algorithm for 100 epochs. In each epoch, we randomly select a data point, compute the gradient, and update the parameter accordingly. Now we'll train the model. Let's visualize the result and see how well our model is fits the data. So if I just run this, so here the red line shows the line that SGD learned from the data. As you can see, even though the updates were noisy, SGD was still be able to find a good fit for the data. So to recap, the stochastic gradient descent is an optimization algorithm that updates the model's parameter using random data points, making it more efficient for large data set. It can be less stable than batch gradient descent, but its noise can help to avoid the local minima and find a good global solution. So key takeaways, SGT update parameter one data point at a time. It's fast and scales well with the large data set. It's prone to noisy update, but can help escape local. Thank you for watching. Be sure to check out the other videos on machine learning algorithms and don't forget to subscribe. Happy coding.